Hi and welcome everyone to our webinar. We're gonna start shortly. We just have a couple of people who are still connecting, so we'll give everyone a minute or two until we start, and then we'll walk you through. In the meantime, please feel free to answer our polling that we've set up before the webinar. Okay, I think everybody who is still joining is now in the webinar. So hi and welcome everyone again who just joined. Today's webinar is on how to optimize your cyanide control. Today's speaker is going to be Margarita, who's our mining solutions specialist, and myself, I'm Benedict. I'm the founder and CEO of CyanoGuard. Just before we started, we did a quick poll to see where everybody's joining from and what your background is with our topic today with cyanide control and cyanide monitoring. So we're going to share these results real quick and discuss them. So I see most attendees today are joining from the Northern Americas, which is great, but I think we have a quite well distribution across pretty much most of the continents. Maybe some attendees from South America is going to join later. Still quite early. And our second question was whether you have personal experience with cyanide measurements, monitoring or control. And most of you do have. That's really great because it's one of the main topics, or one of the main challenges that we're going to discuss today. And all of you, that's really impressive. All of you are aware of the challenges of cyanide monitoring and control. Which is, I think, a very, very good basis for our discussions later and for any questions that you might have. And I think with that, I would like to introduce you to our agenda today. So we're going to start with a short recap on the role of cyanide in gold mining and what are like the most common challenges with cyanide monitoring with existing traditional technologies. Then we have prepared a short checklist for operators to understand whether you might need to review a cyanide testing process, because that's sometimes hard to understand whether you actually need to make changes. After that, we have summarized a list of 5 quick fixes, 5 quick topics that you can revisit that can help you to mitigate some of the errors immediately. And after that, we're gonna introduce you to our approach to our technology, which we've seen can provide for many mines a long-term and permanent solution for many of their challenges when it comes to cyanide monitoring. And after that, my colleague Margarita is going to introduce you to our pilot project program, where you can sign up and see whether it might be useful for you to try out our solutions, our technology at your mine. And at the end, so approximately in about 30 minutes or so, we reserved the end for Q&A. So if you have any questions now or during the webinar, please feel free to submit them using the Q&A button at the bottom of your Zoom application, and you submit them and we'll try to answer them at the end. Okay, so let's get started with a quick recap. As most of you know, cyanide is the most commonly used and only really industrial viable compound that can extract gold from ores efficiently. And it's a key cost driver, not only due to the high consumption, but also to the ever rising prices. And what we've seen is that many mines with declining ore grades require more and more cyanide, and that also leads to high demand in cyanide. Actually, in one of the mines that we work with, we've seen that just the cyanide purchasing costs were exceeding more than 60% of the processing costs. And that's quite a big topic for many mines looking for ways to optimize their process and reduce their cyanide consumption. The big challenge with cyanide is really to get it right. And you see the challenge, or the two alternatives on the next slide. So on the one hand, you have the possibility to just use an excess of cyanide, but that's going to be very costly due to the prices of cyanide, and also to the fact that if you're discharging your solutions, you need to detoxify cyanide, and detoxification costs can be quite substantial depending on the setup of your mine. On the other hand, if you use too little cyanide, then you lose gold to the tailings and you're not able to extract all the gold that you could technically extract. And finding the balance between too little and too much cyanide, having the right amount, is very difficult because it's a highly dynamic process in most gold leaching circuits. And this is what we try to highlight on the next slide, is the high volatility, or the dynamics of the process. Because not only does the ore quantity change, but also the ore composition can change, and other variables like temperature, humidity, that have an influence on the cyanide consumption can affect the cyanide consumption, and you need to react to it to avoid cyanide over delivery or under delivery. And in our experience, it was very often the case that neither the manual filtration nor automated analyzers provided a solution that really solved the challenge for many mines, because they failed to provide either the desired accuracy, the reliability, or the time to result. And we quickly want to look at two of the most commonly used methods to control or to measure cyanide in gold mining. So the first one, most of you know, are manual titrations, manual silver nitrate titrations with either a potentiometric endpoint detection or a colorimetric endpoint detection. Right now, we're going to focus on the colorimetric endpoint detection because it's the most used one. The most obvious and the most common problem is it's a non-standardized measurement, meaning different operators will perceive the color change differently and therefore get to different results. And this is the first issue. And the second issue is more in a chemical nature. The silver nitrate titration is very common to interferences like copper. And with these interferences, you get an artificially high result in the case of copper, which then makes it impossible for you to optimize your cyanide concentration and have the right amount in your process. Something that is in theory sometimes discussed, but in practice not often realized, is the fact that you cannot measure cyanide with a silver nitrate titration at low concentration due to the setup of a volumetric titration. And we had one instance where I was in a mine and they gave me a sample of allegedly zero cyanide according to a titration, CO3 cyanide. And then we tested it again with our technology, and we realized there was quite a substantial amount of cyanide, just because of the fact that it was not known that the titration cannot measure that low. Around 25 years ago, if we go to the next slide, automated analyzers came up, designed to replace the manual filtration procedure. But looking back at the past decades, they have failed to do so on a broad basis. Some mines are using them, but some have quite big issues with them and reverted back to the manual filtration. The biggest issue we see is that they are based on the same titration technology, just on an automated way, and still have the same interferences. While the automation was certainly very beneficial for many parts in the process, the automation itself also created drawbacks. The analyzers, as some of you might know, are capital intensive and stationary and require regular maintenance and calibration. And these 2 points, maintenance and calibration, if they're not done properly, they can lead to the creation of a systematic error. So if the calibration is not done right, excuse me, if the calibration is not done right, you will have an error throughout your entire measurement process. And we've seen a couple of mines, for example, the Guardi mine in Argentina, that have decided to abandon automated control strategies because the automated analyzers just didn't work for them and were too unreliable, and they were facing too much downtime because their samples, their process solution was just not working with these. And as I mentioned, and I think it's something that's also some of you might have already seen, is due to the lack of a better alternative, many mines switch back from an automated control strategy to a manual control strategy. And this is where we try to come in and help mines with a novel technology that is not based on a titration. But before I introduce you our technology, our solution, we prepared a short list of questions that operators and managers can go through to understand whether their cyanide testing process requires changes. The most important ones is sort of in the top line is to understand whether your cyanide consumption matches your target consumption, whether your actual cyanide consumption matches your target consumption, and on the other hand, whether your gold recovery rates also match your targets. Because if that's not the case, it's very likely that there is an issue with your cyanide concentration, because it's one of the most crucial factors in the leaching circuit. The way that we have this checklist designed to work is that if you answer one of those or more than one with no, then you should probably review your cyanide testing process, your choice of the method and how your process works, and see whether you need to make changes. If you have answered, when you go through them and you think, okay, there's some issues with the process that we're currently employing, we have compiled a list with 5 topics or 5 quick fixes that you can employ already now as a sort of like as an intermediate solution. Is something that we've seen that helped a couple of mines is to evaluate your choice of endpoint indicator. In most cases, running is the best choice, but often depending on the concentration of metals, for example, copper, potassium iodide can be also a good choice. Although it's a little harder to discern the color change, it's something that is worth trying out. And the second stage, you can try to look at the possible interferences that you have in your sample, because we've seen many mines, they are not aware of the plethora of metals and ions that are present in the sample that could interfere with their measurement. And if you have a rough idea, you can roughly assess the quality of your measurement, whether it's likely to be too high or whether likely to be too low. Something which is quite easy but often neglected is the fact that the sampling is not done right. And there's many questions that you can ask. For example, where do you sample? Do all operators take the samples at the same point? What are the sample containers that you use? Are they cleaned regularly? How long does it take for you from sampling to the measurement? If you want to go back more into the lab and actually benchmark your reliability or your accuracy, what you can do and what we also do for our internal lab is that we buy cyanide standards that are produced by reference labs, or you can buy them from chemical suppliers with a known and certified concentration of cyanide, and have them tested by your methods, by your operators, and see if you can recover the amount. That's the first stage. If you want to take it a step further, you can do a so-called spiking method, is where you add to samples of your own process, you add a known amount of cyanide and you test it again, and then you see whether you are able to recover that amount. So for example, if you increase the concentration, let's say by 20 or 30 ppm, then you should be able to recover that. That's on the benchmarking part. And the last one, I think this is something that if any one of you has issues right now with getting a reliable and high quality data pool for your measurements, is to check your reagents and your glassware. And we've often seen that especially the silver nitride solution is either expired or it doesn't have the right concentration, and usually it's a little better to use lower concentration silver nitride solutions, because you get a better accuracy, and the same goes for the glassware. If you have a smaller volume burette, you usually get a better resolution. It depends, of course, in what concentration ranges or in what level of accuracy you need for your for your process. One last point, which is quite obvious, but we still see it happens very often, is that the glassware with which the titration is made is not clean. So make sure that you have a straightforward process, that the glassware is always clean, so you don't have any carryover, which might negatively influence your titration results. All of these quick fixes is something that we've seen help mines to take a step into the right direction, but it will not eliminate the fundamental flaws of traditional cyanide monitoring techniques. And if you are looking for a more permanent or long-term solution, I would like to introduce you to our technology, which we've designed to actually address these flaws and help mines to get to better measurements and thereby improve the process. I don't want to take too long on this one, but I'll quickly explain you how that works. So you have three parts. The first is our proprietary cartridge, where you have a molecule in there, which changes color depending on the concentration of cyanide. How that works is that you take 1 milliliter of your sample, you press it through the cartridge, and based on the concentration of cyanide in the sample, this cartridge will change from orange, red to violet. And what you then do is you take this cartridge, you insert it in our handheld analyzer. It looks like this. Turn it on. And then you select the cyanide analyzer function on the device. You select your range. The ranges are of course customizable, but it's just like as a demonstration so you understand how easy it is. We select the 10 to 100 ppm, we press measure concentration, it takes a few seconds, and then it displays you the result. In our case, that's 20 ppm free cyanide. You can also change the output to equivalents of sodium cyanide, which is very often used if you're working in a more process plant environment. And what's the second thing that you don't see right now is that this result, including my user tag, the GPS location, everything is transmitted to our online platform, which you see on the right side of the slide, where you have all your data stored and available in real time for you to analyze, to export. You can also uplink into other existing systems, for example, process control system or a laboratory information management system. And with this data, make empowered decisions to optimize your cyanide process in real time. And what you also can do is that thanks to the GPS data, you can visualize it on a map. So you, for example, you can see, okay, these are all the measurements that we've taken at this particular sampling locations, and with absolute certainty that it has been taken there and not somewhere else, or there has been no mix-up of samples. As I said in the previous slide, and one of our main goals when creating the solution is to address the most crucial drawbacks of existing technology. One of the most important ones for us is the higher reliability and resistance against interferences. And this is due to our completely novel proprietary sensor molecule that is much less susceptible to interferences. So for example, we have no interference with chloride, with copper. We are much less susceptible to the pH of the solution. And that helps the operator to get basically a much better quality data than if they would use a manual method. On the other hand, we also try to make the whole system, also the device, as robust as possible. For example, our devices do not require any calibration. And how do we do that? Is for every measurement of a cartridge, for every cyanide measurement, there's a blank measurement done, which compensates for example, for sensor drift. And hence it does not require calibration like an automated analyzer does. So there's nothing that you can screw up with a calibration, because you don't need a calibration. Since every measurement uses an extra and a single individual cartridge, which are individually quality controlled, there is no carryover or inclusion of systematic error. For example, if you would look at the electrode or reagent solution in an automated analyzer, which could have an error or a mistake, and that would carry over through your whole measurement process without without the operator necessarily being aware of it. Also, our recognition pattern recognition algorithm actively recognizes wrong measurements, or if there has been a mistake in the sample preparation, and then discards the measurement and requests the operator to do a new one. And this is why we can actively avoid and minimize errors. Besides our chemosensor being much more sensitive and having lower limits of detection, we can guarantee a much lower variability if you, for example, if you have different operators or if you have different samples. Something that the operators that use our device told us they like a lot is that it's very user-friendly and very straightforward to use, and also it's safe for them. They don't need to worry about any hazardous substances or taking large amounts of high cyanide containing samples, because for us you just need 1 milliliter. And that's also something that for us when we developed that technology was very important. We focused very much now on the technical advantages of our solution, but I quickly want to highlight and touch on the economical and financial impact that our technology can have. We've seen that mines that use our technology and implement our solutions can substantially decrease their cyanide consumption through more efficient, reliable, and real-time cyanide monitoring. And also as a consequence, the excess cyanide in the tailings is reduced, leading to a lower or even zero detoxification costs, depending on the detoxification process and the situation of the mine. And what's more, in a couple of instances, we have been able to identify cyanide under delivery in real time in the process of our technology. And with that information that was available in real time, helped the mine to redose the cyanide and optimize the recovery rate of gold that would have been normally lost to the tailings. These are just average percentage relative to what you've been using before. If you're interested to find out how large your savings can be for your individual site, I would invite you to visit our website. We're just in the process of publishing our novel ROI simulator and calculator tool, where you can input your own site data, for example, your production figures, how much cyanide you use, and it will give you a rough estimate of how much savings potential and performance increase potential you have for your individual site parameters. Now my colleague Margarita will present you our new pilot program that is designed to help you to try out the technology and see if it works for you. And Margarita is gonna tell you what's so great about it and how you can join it.
Thank you, Benedict. Dear ladies and gentlemen, thank you for joining us today. As Benedict mentioned, my name is Margarita, and I'm responsible for mining accounts at CyanoGuard. Today, I would like to tell you about our pilot program. We've introduced it this year, and it is open for registration to future participants. The objective of this program is to test and evaluate the feasibility of using CyanoGuard cyanide control solution in the production settings of the partner mines. This evaluation will be done against the predefined criteria in comparison with the current cyanide control solution used at the mine. We will send our product kit to you, and it will be used there at the mine throughout the duration of the pilot, which is anticipated to be around 4 weeks. Now I would like to tell you a bit in more detail about the stages of our pilot program. First of all, in order to qualify and set up the pilot, we would need some technical inputs from your side. I think they are, they are easy to provide because you definitely follow them. It's the testing, cyanide testing frequency, and also concentration ranges to be measured. Afterwards, we will establish the baseline parameters, which will later be used for evaluating the project success. In particular, they include simplicity of use of the cyanide control solution, impact on cyanide consumption, impact on gold recovery, and impact on detox reagent costs, if this is applicable to your mine. As a next step, we will send you our product kit and provide the necessary onboarding and support before and during the pilot. I would like to highlight that the onboarding is not difficult. It can be done online because as you've already seen from the demonstration, short demonstration which Benedict conducted, the solution itself is very simple and intuitive. It's very easy to use, and even I would say a 5-year-old kid could manage it. So no lengthy preparation is also, the pilot itself does not require any lengthy preparation. After the pilot, we will conduct the evaluation of the project success and also of the performance of our product kit, and make the decision regarding the feasibility of our further cooperation. Now I would like to share with you the feedback we've received so far from the mines who already work with us. We've basically asked them what they like the most about our product, and they've emphasized a number of factors besides the very obvious immediate positive impact on the operational efficiency and financial performance. In particular, they mentioned that they really appreciate that no capital investments are required. Basically, it's only cartridges and the CyanoGuard device which is rented by the mine. There is no production process changes implied whatsoever. As I've already mentioned before, we will provide all the necessary onboarding, but yeah, it is neither extensive nor requires any special knowledge or professional qualification from your employees. Also, the pilot agreement itself does not imply any long-term commitments, so you would be able to decide upon the pilot either you would like to continue using our product or not, and yeah, either you would like to partner with us for the longer run. And the results will be seen immediately, and they will be 100% transparent. So at this stage, I would like to encourage you to visit our website, download some additional information, or get in touch with us, and if such information is required, and sign up for our pilots. Yeah, so this is exactly a good time for you to sign up for our pilots, which will most of them will start in September. Yeah, and now we will proceed to the Q&A session. So I would ask you to submit your questions if you didn't do so yet. We will aim to answer as many of them as possible, and yeah, if we don't answer all of them, we will get in touch with you on an individual basis so that your question doesn't remain unanswered. Thank you for your attention.
Thank you, Margarita. Yeah, well, let's give it a minute or two. I see some people are still typing up questions, so let's wait a bit until everybody has had the opportunity to type in their question, and we'll answer them. Okay, we received a couple of very good questions. We'll try to answer most of them if the time allows. Otherwise, we'll get in touch with you afterwards. So the first question was directed towards the pilot program. And I think it's something that you can answer, Margarita, is whether is there any restrictions on who can participate, or can any gold mine participate in the pilot project, Margarita?
Yes, basically most of the mines can participate, of course, but there are some pretty obvious criteria which a mine should fulfill. It should be an operating mine which has a cyanide-based leaching process. Ideally, it should also have a mobile coverage on site. But just in case there is no mobile coverage, we can come up with a solution. So it just wouldn't be probably the optimal case. And for the moment, we are focusing on the mines which measure cyanide in the concentrations up to 500 ppm.
Thank you, Margarita. And we received a couple of more questions in the meantime. So I'm going to start with the second one here. The question was whether this is an online measurement. As far as I understand it, you mean if it's inline inside of the process. So how the measurements or the current system works is that operators take the sample and measure it directly at the point where the sample is taken with the device. We're working on an online analyzer, which will be available in probably in 2021, but at the moment it's still requires the operator to take a sample and push it to the cartridge. The next question was what are the disposal considerations for the spent cartridge? And this is a really good one because we receive that quite often. And the cartridge itself, before it comes in contact with cyanide, contains a proprietary vitamin B12 molecule, which is completely non-hazardous because it's of sort of biological origin. And given the high sensitivity of our system or of the molecule, the cyanide that is contained, or the cyanide that stays in the cartridge after testing, is so low. It's probably lower than you know, if you would have like a third of an almond. So it's completely safe. And for the disposal considerations is that they can be disposed with household trash or normal waste, but what we offer our clients is that we take them back and we upcycle them and reuse them again. The next question we receive is I need to scroll a bit. How long it takes to implement the solution, and as far as I understand, is, you know, how long does it take for you if you receive it and then to try it. So usually an onboarding session takes about 1 to 2 hours, and we can ship daily. We have everything available in our warehouse. So if you say you know, you wanna start in September and start the pilot there, it's a very quick process, and usually it doesn't take more than 2 or 3 days once it has arrived inside to get started. The next question is, can the technology only be used with gold, or can it also work with silver? Certainly it works for any, let's say, liquid sample that contains cyanide. We have clients that use it for wastewater monitoring in the chemical industry here in Switzerland. For example, they're also organic, so there's no problem using it with silver. The next question, and I think this is one for Margarita, is would a company participating in a pilot have any obligations to CyanoGuard during or after the trial?
Basically there are no obligations except for the readiness to share the information which is relevant to our product usage during this during the period of the pilot. So there is no obligation to enter into separate commercial agreement, but yeah, there are high chances that you would like to do it upon the pilot.
Thank you, Margarita. We received another question. It's actually twofold. So the first question is, what are the upper limits for the testing? So we can develop custom solutions for most of the ranges that are necessary. For the pilot, we would like to focus on the upper limit of 500 parts per million of free cyanide. If in a commercial implementation of mine requires custom ranges that are higher or lower, we can tailor that. That's not a huge issue for us, but this is something that we would do on a commercial basis only. And the second question is for a CIP process where concentrations vary. It goes typically up to 500 ppm. This is something that we can already do in a pilot project, and usually we adapt the sensitivity of the cartridges or the detection limits of the cartridges and the devices. They work for all different ranges. So we have cartridges for very low ranges, for example, from 0 to 1, which have a much higher resolution, much higher accuracy than if you, for example, use a cartridge that has a range from, let's say, 100 to 500 ppm. This is something that we can tailor based on the requirements of an individual mine. So let's see if we have still some open questions. I think there's still a couple of them coming in, and I think a really good one is what are the costs for the solution? We'd love to give each one of you, or a specific person who asked the question, perfect answer, but this really depends highly on the testing frequency and on the individual requirements of the mine. And as we've seen, or the mines that we work with, they can be very different from site to site. So to understand the savings and the costs for your particular site, we would be happy to provide you with a quote, or you can also use the ROI calculator, which gives you a rough indicator on our website. But if this is of interest to you, please go and visit our website where you can request a quote. The next question we received is, could CyanoGuard also be used to sample environmental media, for example, stormwater spills? This is a very, very good one. We have done in the past, and I know of 2 clients which still use it to do environmental measurements. So this is one of the advantages of our system. It works with most samples, even if they have a very high solid content. They have a filter integrated, so you don't need to pre-filter them. You could just simply press it through the cartridge and works right away. So stormwater spills, even very turbid high with a high solid content, that would work. I think we have time for 1 or 2 more questions. And one question I personally found very interesting is about the artisanal and small-scale mining communities. I'll just read the questions. We work with artisanal and small-scale mining communities, assisting them to move away from mercury amalgamation. In many cases, they move to small-scale cyanide leaching. Are your offerings relevant to small-scale operations, and can they help to add value? This is a very, very good question, and actually it's also something that we've been trying to in the past to get in touch with actors in that area, because our solution is very, very simple and doesn't require any setup. So everything that you need basically comes with the kit. Maybe show you real quick. This is like one of these cases that we ship, and there's everything in there that you need for let's say a couple of days of testing. And you can do it anywhere. You just basically need some kind of electricity to charge the device, and I'm sure this definitely can provide value. And I think we'll get in touch afterwards to see whether there's a possibility to try this out even further. And I think this is going to be the last question for today. Can you explain again why technology does not need to be calibrated? Also a very, very, very good question, which we get very often. The way that our system works is that our devices have an internal calibration against a known standard. And with every measurement, sort of every time the the device makes a measurement, so it analyzes the color. It compares that against a set of values that has been sort of the algorithm has been created before. And from this comparison that is done at every measurement, against sort of for every measurement, you would be able to do it without a calibration. So, for example, the concentration range that, let's say, 10 to 100 ppm that you're using is already on the device, and it's integrated. And then every time you do the measurement, it's compared the value that you measure against the value that has been measured in the lab. So you can compare it against that. And this also accounts for sensor drift, because the blank measurement that is done with every real measurement always provides value. So if the sensor would drift, you would have sensor drift on both measurements. I think that's all. Just looking at the time, if we have time for one more question. I think that was our last question for today. If we didn't answer your question in this session today, or we missed it, we'll make sure after the call to go through all the questions again and get in touch with you. And also, if you have any further questions, please get in touch. You find on the next slide, you find our email address, and I would invite you to get in touch if there are any further questions or ideas. At this point, I want to thank everyone for attending and for the great questions. We hope you found it helpful. If you have any feedback or any suggestions for further topics that you would like to share with us, please feel free to do so and send us an email to miningsolutions@cyanoguard.com. And what we'll do in the next couple of days, we will share the recording of the webinar with you and the slides in the following days. We'll also put the checklist on the blog in the next day, so you can have that for your materials. And in the meantime, I would like to invite you to visit our website, where you can, as Margarita mentioned, request more information or learn about a pilot. And I hope that you will join us again in our next webinar, which will be in approximately 1 month. And until that, I wish you a great morning or afternoon, depending where you're located. And yeah, stay safe. Bye.
Thank you. Bye.